Okay, so in the last class, we were discussing about the subnetting, right? So first thing that we discussed is subnet mask. So in this, we have discussed that subnet mask is used to identify network part and host part of the IP address. Now, how will you identify the network part? Means number of one represent network part, whereas number of zeros represent what? Host part. And you know that this is going to be fixed, means we cannot change. It cannot be changed. What can be changed only? The host part can be changed, right? So next we discuss that we have one term called as a block size. What is this block size? Block size refers to the size of subnet block, right? The size of each subnet block is called as a block size. Means if you are having each subnetwork, so what is the range of that each subnetworks? That will be decided by what? Block size, right? And subnetting is what? Subnetting means dividing the larger network into the smaller small subnetworks like this. And each subnetwork is going to have certain range, and this is referred to as a block size. Here also we'll be having the range, same range we will be having here also. So this is also according to the block size, right? Then after this, we discussed about the class A, B, and C. In that, we have discussed that class A, the default subnet mask of class A is what? 8. That is, we call it as a 255.0.0.0. It means that in the class A, this is called as a network part. And this is called as what? Host part, right? So in this, we are going to have more options for changing purpose, more options for host purpose, but less option for the network part. It is going to be fixed. Then when we will come to the class B, here we have default subnet mask is 16. It means 255.255.0 and 0. In this, these are the network part that is fixed, and this is what? The host part. So compared to like class A, we have less number of options for changing purpose for the host part. That's why we call it as a, this one is for the larger network. This one is for the medium size network. And the last one, that is class C, is for the small network. So in the class C, the default subnet mask is what? 24. It means it is going to be 255.255.255.0. And this all three is what? Network part. And this is going to be the host part. Till here we have discussed in the last class, and also we have done the subnetting of class C and class B, right? I think I have given you one question also. Have you done that? You want me to solve? Huh? Okay. Fine. Okay. Then we will start with the class A, right? So what was the question? Tell me. 150.0.0.0 slash 19. Okay. So first thing we have to observe here that this IP belongs to which class? It is of B, right? The range is from B. Next, it is 19. So how will you write this 19? 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 16 we have written. 3 more will come. 1, 2, 3, and rest will be what? Zeros. 1, 2, 3, 4, 5. Dot 1, 2, 3, 4, 5, 6, 7, 8. Right? Then value will be what? 255. Dot 255. Dot what is the value? 220. Then 0. Next, we have to calculate here block size. So block size will be 256 minus 224. The value we'll get is 32. Next, number of subnetwork is equal to 2 to the power number of extra 1. How many extra 1 we have? 3 extra 1 we have. So 2 power 3 is what? 8. Then number of host per subnetwork. That is what? 2 to the power number of zeros left. How many zeros are left? 8 plus 5, 13. Then usable, minus 2 will do, right? Then we will write, so 150 dot 0 dot 0 dot 0. Then 150 dot, see, 0. Next is what? Because this is class B. So in class B, first and second octet is always fixed. So no need to change that. What we will change? Third one. So what is the value we have got 32. So what we will write? Dot 31. Next, 255. Right? Then 150 dot 0 dot 32 dot 0. 150 dot 0 dot 32 plus 31, 63 dot 255. 150 dot 0 dot 64 dot 0. Then 150 dot 0 dot 95 dot 255. It means total subnet works 8 we will get here. So the last one will be what? 150 dot 0 dot 224 dot 0 and 150 dot 0 dot 255 dot 255. Same, same you have got, everyone. It is very simple. Look, see, you are knowing that last will be 255. What we are adding? 31. So subtract 31 from this. You will get 24. What we do? We add from this number, we are adding this number to get this number. No. So we have this number, that is 255. And this number is written, that is 31. It means when we will subtract it, we will get what? 224. Opposite we have to do. Instead of adding, we have to subtract. That's all. Correct? Everyone got the same answer? Next, class A subnetting, right? Class A, class full subnetting. Today we have to complete subnetting part. So now we'll take any IP of class A, let's say 10.0.0.0.0/8 we'll take. So if I'm taking slash 8, it means what? This is class full because this is default subnet mask. So how will we write this 8? 1, 2, 3, 4, 5, 6, 7, 8. Rest will be what? Zeros. 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. 255 dot 0 dot 0 dot 0. So block size when we will write is equal to 256 minus 0 is equal to 256 only. Then here there is no need subnetworks because only single network we will get because it is default subnet mask. So when you will write 10.0.0.0, then 10 dot. See here what we change? Second octet. So what is the range you have got here? 256. So what you will write? 255. Rest. Whatever we are doing in the class B, let's say here we were writing the last octet also with 255 only, no? Here also we have to do the same thing. 255.255. Getting? Correct, no? Means we have to fill all the octet with what? 255. Which octet? The octet which is being changed. So here all these 3 octets are being changed. It means if it is being changed, now we have to complete this 3 octet with the 255. This is what classful. By classful because we have taken here default subnet mask. Now what will happen if you will take classless? So class A, classless subnetting. So in this same question, we have taken 10.0.0.0/8. Sorry, slash 10. It's a 10 we will take. 2 extra. So again, same concept. 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 255 dot 192 dot 0 dot 0, right? Then block size is equal to 256 minus 192, that is 64. Next, number of subnetwork is equal to 2 to the power number of extra one. How many extra one we have? Two extra one we have, right? That is going to be what? 4. It means number of subnetwork will be less, but host will be more. See how? Number of host per subnetwork is equal to 2 to the power number of zeros. How many zeros? 8 plus 8, 16, and 16 plus 6, 22. Right? And number of usable host, just we have to subtract 2. Is equal to 2 to the power 22 minus 2. Then we will write 10 dot 0 dot 0 dot 0. 10 dot, what is the range we have got? 64. So what we will write here? 63 dot 255 dot 255. 10 dot 64 dot 0 dot 0. Then 10 dot 127 dot 255 dot 255. 10 dot 128 dot 0 dot 0. Then 10 dot 191 dot 255 dot 255. Then 10 dot 192 dot 0 dot 0. Then 10 dot 255 dot 255 dot 2. Clear? This is for class A, classless submitting. Now you see what will happen. Whenever, like here, how you will get more numbers of IP addresses. See, first calculate this one. What is the number of hosts you have got? 2 power 22. What is the value for that? Use calculator, tell me first. 2 power 22 is equal to, the value is going to be 4194304. Okay, 41,94,304. Now, see what you do, you calculate the same thing. When you are starting from 0, ending at 63, what is the value you got? 64, multiply. Starting at 0, ending at 255, what is the value you're getting? 256. Same here also, 256. And calculate this. 64 into 256 into 256. Same value we have got. Correct, no? They both are matching, no? It means this is the correct, whatever we have written. And here also we have got the same value. Yes. This is how you can verify the ranges that we have written here. It should match with what? Number of hosts per some networks, whatever you're writing here, right? Correct? So which one was easy? Class C, Class A? Class A is easy. Now we will do A to B, A to C, then you see what will happen. Till it is clear, no? I think no, it is not required to take any further questions from the Class A. Not required? Then we will do Class B to Class C. Right? What does it mean when we are tagging Class B to C? Means IP will be of which class? B. And subnet mask? C. So Class B to Class C subnetting. Let's say we have taken 172.16.0.0/26. So this IP belongs to which class? B, and subnet mask we have taken is from C. So same thing, 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, 2, 3, 4, 5, 6. 255 dot 255 dot 255 dot 192. Now you will tell me what is the block size? Block size 256 minus 192, that is going to be 60. Number of subnetwork you have to tell me. What is the number of subnetwork? 2 to the power number of extra one. How many extra one we have? How many of you say 2? Why 2? Because 24 is the default and here we have written 26. That's why. Tell me this IP is of which class? B. What is the default subnet mask of B? 16. What is it in here? How many extra one? 10. 10 extra one. How many extra one? 10. You have to compare with the IP. This is of which class? B. And this is the default subnet mask of B is what? 16. And here we have to do 26. So it means 10 extra. 2 to the power 10. These many subnetworks you have to write. Is it possible? What is the value of 2 to the power 10? 1024. 1024 subnetworks we will be getting here. Correct? That's why, see, what happened that earlier we were having subnetting. So that subnetting was limited to only the same classes. But it was also not enough to handle the number of users. That's why what happened? Again, we have to start with the B to C, A to B, A to C, like this concept. So now what you will find? Always you will find that IP can be of any classes and subnet mask will be of any classes. Right? We may get IP 10.1.1.1/24. It means A to C. Here, according to what we have written here, it is B to C. Right? Now, number of host per subnetwork is equal to what? 2 to the power number of zeros left. How many zeros are left? 6 only. That is what? 64. And number of usable host per subnetwork is equal to what? 64 minus 2. That is 62. Then you will write all these values. So 172.16.0.0. 172.16. Now, here is the question that we know that in class B, which octet we change? Third also, fourth also. So according to the block size that we have calculated, as we are moving from B to C, so first we will change the fourth one. What we will change? Fourth one. So what you will write? 0.63. Okay. That's why I was telling you, that submitting is easy. But when you move from A to B and A to C like this, then certain problem happens. Here you have to focus and here you have to understand. Next is what? 172.16.0.64. 172.16.0.127. 172.16.0.128. Then 172.16.0.191. 172.16.0.192 and 172.16.0.255. Done? See, like what we are doing here, that This IP belongs to class B. Subnet mask is of class C, 26. So according to the concept of class C, what we change? Fourth octet. So block size we have got here 64. So we have to fill first fourth octet according to the concept. Because in this, if you will observe, which octet is being changed? Last one. Which octet is changing here? Fourth one, no. So fourth octet we have to change. So what we are writing, 0 will start. As I have to reach 64, I am starting from 0. So I will write here what? 63 only. Then I will get what value? 64. Then again you will write what? 64, 127. You will add what? 63 plus 64.
Because it's from C to B, we have to change there.
Hmm. Generally, we move forward. We can move backward also. That is also possible, but that is very limited. Always you will find this forward direction.
Third up.
Huh. Depends. Right. So now you see. So 64, 127 we have written. 128 plus 63, 191. And 192 plus 63, 255. But here, how many subnetworks I have written? 4. What is written here? 1024. Then how you will get this 1024? See, now you have changed only fourth octet, no? But we know this IP is of which class? B. And in B, even we can change third octet, right? So now next method is what? 172, 172, 16. Wait, I will copy this. No need to write all this. Same thing will be there. Copy, paste. Just what will change? This is going to be 1, 1. This is 1. This is 1. This is 1. Saying this is 1. You just observe what is happening here. It means what we did. First, we filled the third octet with 0. After 0, what comes? 1. Next, what we did, we filled the third octet with 1. Then completed all the process from 63 to 255. Then after this, what we'll do? Again, you will fill the third octet with 2. Then 3. Then 4, 5, 6. Till what? Till 255. Till 255. So again, same thing will be there, right? So here what you will change? Just 2 will come. Here also 2 will come. Yeah. And what is the last one? Last one is 172, 16, 255.0, 172, 16, 255.63. Then 172, 16, 255.64. Then 172, 16.255.127, 172, 16.255.128, 172, 16.255.191, 172, 16.255.192, 172, 16.255.255. If you are able to do all these things, then you will be pro in the submitting part. These things. Yes, and I want you to be pro in the submitting. If anyone is giving you any question, very easy to solve. Just you have to understand the concept here, how it's working. And you have to remember the concepts. Default submit mask, how what is this, and how it is being changed when you move from A to B and A to C like this, or B to C. Is it clear or not? Everyone, online students, is it clear?
Yes, sir.
Everyone, it is clear? Okay, then I will give you one question and you have to solve, right? So what do you want? You want me to give private IP or public IP? Concept remains same. Whether you use public, whether you use private. Okay, same you try 172.16.0.0. And this time, instead of, okay, I will give you very simple now, 25 volt. Very simple, I'm giving you 25/25. Try to solve this. And what you have to do, you have to calculate block size, number of subnetworks, number of hosts per subnetworks, and just you write like this only, but just you write with 0, with 1 and 2, that's all. Try. Done. Here it is clear what we have done. First, we have calculated the block size according to the slash simplify. So we have written here that one extra we have got. So according to that, 128 will be the value. Then you will calculate block size, that is 256 minus 128. The value you will get here is 128 only. Then number of subnetwork is equal to what? Number of extra one. This IP belongs to class B, and the default subpass of class B is 16. And here we have it in 25. 25 minus 16 is going to be 9. 9 extra, right? So 2 power 9, that is 512. Then number of host, this one, and number of host per subnetworks, means usable host is going to be right. And then we have calculated using first 0.0, then after that 1.0, then 2.0, then what will come? 3.0, 4.0, at last 172.16.255.0, 172.16.255.127, 172.16.255.128, then 172.16.255.255. And this is going to be the last one is what? This is a 512th subnet box. Clear? If it is clear, I will start with A to C, then A to B. One example I will take from A to B, one example from A to C. Right? Class A, let's say 10.0.0.0 slash 17. It is class A to B. A to B. Okay, let me write the heading. So class A to class B subnetting, right? After this, I will tell you one website name. There you can write the IP, you can calculate the subnetworks, fine. Okay, but that is at last, not first, okay? Because it might be possible that when you are going for the interview, they will not ask you that how many, you have to find the network addresses and how many subnetworks we will get. They will ask you that, see, this is the scenario. I have 100 PC. Tell me which subnet mask or which class of IP I should take so that there should be no any wastage. This is the question. Okay, like I have 50 PCs. Tell me the subnet mask that I should take to reduce the number of wastage. There you have to calculate without pen and paper, right? So when you will be doing all these things, then it will be very easy for you to understand the scenarios. It is asked recently only one student has been asked the same questions that this is the number of PCs I am having, what IPs I should take or which subnet mask I should take so that we can reduce the number of wastages. Okay. And if you know all these things, it is very easy. Correct? No? That's why keep practicing about this, whatever we have done, even whatever we have done yesterday also. So A to B means what? 10.0.0.0. Let's say IP will be of which class? Class A. Then subnet mask will be of which class? B. So let's say we will take here 70, one extra. So 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. And 1 and 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 255 dot 255 dot 128 and dot 0. Right? So block size will be what? Block size is equal to 256 minus 128. That is going to be 128. Next is number of subnetwork is equal to what? 2 to the power number of extra one. Tell me how many extra one you have. Yes, this belong to A. So default is about 8. So 8 plus 1, 9. 9 is the extra one. So we will get here 512 subnetworks. Correct? Number of host per subnetwork is equal to what? 2 to the power number of zeros left. How many zeros are left? 8 plus 7, 15. Then number of usable host per subnetwork is equal to 2 to the power 15 minus 2. Then you will write 10 dot 0 dot 0 dot 0. 10 dot. What we change here? 0 dot 127 dot 255. Because what we are changing? Third one. Next 10 dot 0 dot 128 dot 0. Then 10 dot 0 dot 255 dot 255. Then what you will do? Again with 1, 2, 3, 4 like that. So next will be what? 10 dot 1 dot 0 dot 0. 10 dot 1 dot 127 dot 255. 10 dot 1 dot 128 dot 0. 10 dot 1 dot 255 dot 255. After this, 2, 3, 4, 5, 6, still what? 255. So at last, what we will get? 10 dot 255 dot 0 dot 0, 10 dot 255 dot 127 dot 255, 10 dot 255 dot 128 dot 0, 10 dot 255 dot 255 dot 255, and this is. You see this question for 3 to 4 minutes every step and try to recall how it is happening. If you find any doubt, Then you can ask me. Tell me, clear or not? Everyone, it is clear? Online students, please confirm. Is it clear? You can unmute yourself and then you can tell.
Yes, sir.
Okay. Done. Now we'll start with the A to C, and we'll learn complete the submitting part. See, randomly you can take like this only, any IP of the class A, then any subnet master of class B, then you can try from yourself also. Next, let's tell. Let's say we'll take public this time, 1.0.0.0. Let me write first. Class A to class C subnetting. Class A, it means what? 1.0.0.0 slash 25. Again, very basic, I'm taking 25 only. Extra one. If you will take 28, 29, what will happen? It will be a very lengthy process, right? Same thing, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 1, 2, 3, 4, 5, 6, 7. 255 dot 255 255 dot 128. Block size is equal to 256 minus 128. That is going to be what? 128. Next is what? Number of subnetwork is equal to 2 to the power number extra 1. How many extra 1 we have? 17. Why? Because this IP belongs to which class? A. And default submass of class A is what? 8. Here, what is it in 25? It means 8 plus 8, 16 plus 1, 17 is extra 1. See, these many number of subnetwork you will get. 2 to the power 17. Is it possible for you to write? What is the value? 131072. 1,31,072 subnetworks you have to write. I don't think it is possible for you to write. Then number of host per subnetwork is equal to 2 to the power number of zeros are left, that is 7. That is going to be 128. And number of usable host per subnetwork is equal to 126. Right? Then what we will write here? 1 dot 0 dot 0 dot 0. 1 dot 0 dot 0 dot 127. Because this is C. A to C, no? So in C, what you change first? Fourth one. Again, change fourth one. Then again 1 dot 0 dot 0 dot 0 dot 128 and 1 dot 0 255. Then again you will change the third one with 1, 2, 3, 4, 5. Then second one with 1, 2, 3, 4, 5 till what? 255. Okay, so last I will write last is going to be 1.255.255.0 and 1.255.255.127 and 1.255.255.128 and 1.255.255.255. And the last one is what? 1,31,072 subnetworks.
Could you explain again that?
Which one?
Second and third of the changes.
Like first, what we are doing here? First, we have written from 1.0.0.0 till 1.0.0.127. Next, we have written what? 1.0.0.0.255. After this, what you will do? 1 dot, let's say 0 dot 1 dot 0, 1 dot 0 dot 1 dot 127. Then 1 dot 0 dot 1 dot 255. Then 2 dot 3 dot 4 dot 5 dot till what? 255. Once it is done, then again you will come to which? Second octet. Same here also 1, 2, 3, 4 till what? 255. Very lengthy process. No need to do that. Just if you are able to understand this much, it is fine. Clear? So class A submitting is done, B is done, C is done, A to B is done, A to C is done, and B to C is done. It is fine. Beyond that, no one is going to ask you anything. So on the Google, you will search IP subnet calculator. You can calculate everything. IP subnet calculator. In that, you can give the IP, you can find what is the network address. You can find what is the block size. You can find all the number of subnetworks. It will display you everything. Clear? So next, we'll start with the next topic. But again, you will require all these things when we will start the routing. Because in the routing, I will give end devices IP addresses and I will ask you, tell me the network addresses. Because so that we can do the routing. Because in the routing, we have to specify what network address, right? So that whatever the IP coming under that network is reachable. Clear? Any doubt, any questions?
Sir, could you tell how do you answer that scenario in the interview question that you told? Suppose we have 50 PCs and
Yes.
which
Next topic is that
IP
one.
address?
See, here only we have. See, there is one term called as a FLSM and VLSM. FLSM is what? Fixed length subnet mask, and VLSM is what? Variable length subnet mask. So we'll understand this FLSM and VLSM with the help of concept. Okay. See here what is written. That you have a team of IT department, HR department, and sales department. It is telling you that number of PCs in the IT department is what? 120. Number of PCs in HR department is 600. Number of PCs in sales department is 28. What you are doing here? You are using here fixed length subnet mask. It means what? Your subnet mask is always fixed, irrespective of the departments. So what you did here, you have taken a same subnet mask that is called as a /25 everywhere, right? Now you know that /25 means what? Means we know that default is 24. 25 means what? One extra I have written. So it is going to be written as what? 1, 2, 3, 4, 5, 6, 7. This you know or not? We know that, correct? So this is 25 and this is written like this only. So the value you will get is what? 128, right?
Yeah.
Now, if the value is 128, it means what this is? The block size, the range, the range of the network means it will start from 0, will end at 128. Means in each networks, I will get here what? 126 IP because you know the network address you have to subtract and the broadcast address you have to subtract. Forget that part. You focus here that okay, I'm getting here 128 IP. Okay, how many IP you got? 128. What is the number of PCs you have? 120. So 8 will be wastage.
Yeah.
8 IP will be wastage. Then in the HR department, what you did, again you have 60 PCs, but you're not changing the subnet mask. Again, you have used 128 only, means 25 only. So again, you will get what? How many IPs? 128. 160 only PCs you have. 68 is going to be your wastage.
Yeah.
Wastage is more. Then in sales department, you have only 28 PCs, but you have used only /25. And again, you are getting what IP? How many numbers of IP? 128. So 100 IP will be wastage. Right? More wastage is there. Why? Because you have fixed your subnet mask. You are not going to change the subnet mask. But if you will change the subnet mask, what we can do? We can reduce the number of wastages. Whenever we are changing the subnet mask. I'm not telling you that you can completely remove the wastage. Not possible. We can reduce the number of wastage. See how. Now what we will do, instead of using FLSM, we'll use VLSM. This is what? Variable length subnet mask. Same thing, IT department, HR department, sales department, number of PCs 120, 60, and 28. Now see, subnet mask is what? Here it is telling 25 only. It means 25 means what? 128. How many wastage? 8. But in the HR department, number of PCs what? 60. What it has done? It has taken /26, not 25. If you will take /26, then you will get 64 as the block size. This is the size of each subnet block. Size of each subnet. And what is the size? 64. How many PCs you have? 60. How many wastages? Earlier, it was 68 wastages what there now. And here what we have done, we have reduced the number of wastages to 4.
We take 26, 2 1 will
Ah, see,
190.
2 1 will come. 1, 2, 3, 4, 5, 6. Its value will be what? Now you subtract 256 minus 192. 64. Correct? I'm telling you, practice is required. It is not that you will sit in the 2-hour class, then you will go home, you will not do anything. You have to do. After class, you have to spend 2 hours for practicing all these things. Then only once we complete CCNA, see, 2 things can be done. I am completing CCNA, you are also completing the CCNA. I am completing, you're not completing. It happens. When I will complete, I want you to also complete. How it will happen? After class, you have to study. Okay, when you will think, no, once CCNA will be completed, then I will start studying. Again, it will take 1.5 extra month for you. That's why continue one by one only. Right? So here, what is the value you got? 192. This is 64.
Sorry, Vishal.
Ah.
Here, for example, like wastage is like four IPs. For example, like every subnet, they must be having like two IPs who are dedicated for like one is broadcasting and one is like network IP. In
Correct.
that case, like how can be like four wastage?
No, what we are doing, we know that one is going to be network part and one is going to be the host part, sorry, broadcast part. So we are forgetting that part. here we are focusing that let's consider that we will use all the IPs, right? Based on that consideration, we are calculating here.
Yeah, got it. Got it. No worries.
Hmm.
Thank you.
Next is what? See, in the sales department, we have 28 PCs, correct? And here what you did, you have taken /27. It means 1, 2, 3, and 1, 2, 3, 4, 5. What is the value? 224. Next, 256 minus 224. What is the value? 32. 28. You have got 32, 4 wastage. Technically, it is going to be 2 wastage. Why? Because one is network part, one is broadcast part. So remaining is a 2 wastage will be there. Correct? If we calculate according to the real concept. So this is the benefit of using variable length subnet mask. And this is how you can identify based on the numbers of PCs the question is being asked, what subnet mask you have to take. Right? Confirm me fast. Correct? Clear? So what is it in here? That fixed length subnet mask is a subnet deployment strategy in which a block of IP addresses is split into the several subnets of identical length. In the FLSM, it is of identical length. FLSM divides a network into subnets of equal size using a fixed subnet mask across the entire network. So where it is suitable? Suitable for the network where all the subnets requirement is of identical size. Means just you have taken one time subnet mask and just you are doing the calculating or you are doing the calculation based on the simple single subnet mask that you have taken. That's why it says what? It is simplifies the subnetting part, network management by using the uniform subnet size. So it is going to be easier to implement and understand where in the smaller subnets. But what is the demerit of this? Wastage of IP address will be there. Wastage of the IP addresses will be there. Whereas when you will come to this VLSM, the wastage is reduced. And what it says, VLSM is what? Variable length subnet mask allows for subnetting networks into a subnets of different size, optimizing the IP addresses allocations by using subnet mask tailored to each subnet specific needs. Means according to the specific needs, we will be taking a specific subnet mask. What it does supports hierarchical addressing by allocating the larger subnets to the high density areas and smaller subnets to the low densities area. Wherever we have higher requirements of the IP addresses, what we are going to take here, larger subnets. Then we have less smaller requirement, lesser subnets. So what it does efficient utilizations of the IP addresses, and it reduce the number of wastage of IP address. Clear? Disadvantages of VLSM, we can say that it requires always calculation. Always we have to decide. It is complex to calculate. Clear? We'll start with the next topic. OSI model. Now you tell me, what do you mean by this term OSI? Okay, first question to you. Which was first developed, TCP IP or OSI? Which was first developed? First TCP IP model was developed. It was having 4 layers. Then OSI model was developed. It was having 7 layers. Later on in the year 1990, we have TCP IP updated model, updated version that has 5 layers. This is a scenario. TCP, OSI, again TCP, like this. So now you tell me what is the requirement of having this IP, OSI model or TCP IP model? What led to the development of this OSI and the TCP IP? What is the requirement?
Send the data packet every operating system same way.
That is fine to send data packets, to transmit from one location to another location, everything. Okay. So why this OSI only? Why not any other protocol? Sorry, means any other models?
OSI is standard.
Hmm. Standard model. So why you call it as a standard model?
Because every operating system will be support.
Everyone will support OSI, right? It means you want to tell here that every vendors. Earlier, see what happened, that different manufacturers were there, different vendors for the different products. So they used to manufacture their products based on their own models, right? So let's say, for example, we have certain products of HP and certain products of the Dell. So if you have to enable the communications between the Dell product and HP product, you have to know both the models for communication purpose. Is it possible for you? Is it possible for us to know all the like different communication layers? Not possible. It means that at that time, universal standard language was missing or universal model was missing. That this is the set of rules that has to be followed with all other vendors. Means there will be a single rule, single model that has to be followed by all the departments, all the manufacturing departments. See, this is written here. History leading to the TCP and IP. For example, IBM, the computer company with the largest market share in many markets back in the year 1970s and 1980s, published its own system network architectures in the year 1974. Now, other vendors also created their own proprietary networking models. Means other vendors also started having their own models. Now, as a result, if your company bought computers from three different vendors, you have what? Computers from three different vendors, then network engineers often had to create three different network based on the networking models created by each company, right? So you have bought HP, Dell, and Acer. So all this has separate models. You have to deploy all these separate models to enable the communications between all these devices. Three different vendors, three different models. So it was not efficient. That's why then somehow connect those networks, making the combined networks much more complex. To overcome with this, we have TCP IP model that we say is a transmission control protocol, internet protocol, right? But see what happened that it was developed by Department of Defense, US Department of Defense. Then to understand all the layers and like this is what this is TCP IP was generally for transmission purpose, but OSI is not for transmission purpose. This is for theoretical understanding.
Not practically.
This is not practically. This is for theoretical understanding of the how transmission will take place. So what we are doing here, we are going to elaborate that layers. What we are doing, it is being elaborated. We were having how many layers? 4 in the TCP/IP. Then we have elaborated in the 7 layers of the OSI. So now you see what it says that OSI is what open system interconnection. It was developed in the year 1980, around 1980, 1984. Approximately 80, you can say. So OSI is what? OSI model is a conceptual framework that standardizes the functions of a telecommunication or computing system into the 7 distinct layers. Here we were having 7 layers, right? It was there for the theoretical understanding, right? Then It was developed by whom? ISO. That is International Organizations for Standardizations. Correct? OSI uses a term. Okay, we'll come to that part, what it uses. It has how many layers? 7 layers. So we'll write all the details about the OSI layer now. Open system interconnection. It is an universal computer network language. What it is? Universal computer network languages, right? It means that whatever the different vendors we have, they all will use this OSI only for understanding purpose. Correct? How many layers we have? It has 7 layers. What are the layers? So we'll start from the bottom only. First is what? Physical layer. Second is what? Data link layer. Session layer, not seasonal. Application. Clear? Either you have to trade from physical to the application, or you have to trade from the application to the physical. This is a sequence you have to follow. So physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and the application layer. So first we'll start with the physical layer. What is the function of the physical layer? To establish physical connectivity between the devices and enable physical transmissions of the data. It is responsible to establish physical connectivity between the devices and enable the physical transmissions of the data. So what could be the examples for this physical layer? Cables, right? The connectivity cables. Then we have one certain physical layer devices like hub, like repeater. Correct? Even we can have 802 dot, I think 11 for wireless it is. Or we need to write only wireless. Wait, I will write that it can be wired or wireless transmissions. Huh? No. A router is not an example of physical layer.
Wi-Fi is the Wi-Fi.
I'm telling you wireless transmission can be the examples. Apart from physical cables, how we enable the transmissions. Wireless transmission, radio frequencies. That is the example. Huh? That's- So to establish the physical connectivity between the devices. Now, in this, data units is called as bits. See, generally, we call it as a layer 1 PDU, layer 2 PDU, layer 3 PDU, protocol data units. Right? But when you will come to according to the TCP IP model, so in the first one, it is going to call it as a bits. So I'm writing here only as a bits because we have like it is more detailed version on this file. Correct? And in that, what we will find, the versions had the different layers has been combined to form some single common layers. That's why. Okay. So in the PPT is also it is written that what is this? Physical layer deals with the physical connections and electrical specifications of the devices. It defines the physical characteristics of the medium used to transfer the data. How the data will be transmitted, that is there in the physical layers. So it does what it does with the physical connectivity, physical connections, and electrical specifications. So even you can add one more point to establish the physical connectivity and electrical specifications to convert in the signals. This is the work of what? Physical layers. Or in short, you can tell that it is called as a layer 1 PDU. Because according to the OSI, we call it as a layer 1 PDU. According to TCP IP, we will call it as a bits, frames, segments, packets like that. But as we are referring with the OSI only, so here only I am writing all these things. Next is what? Data link layer. Yes, what it does, it enables the transmissions based on MAC address. Data link layer is responsible to have the communications between the devices based on the MAC addresses. It enables error-free transmission here also it is written, manages access to the physical medium, error detections, corrections, provide node-to-node connectivity. How node-to-node connectivity? With the help of addresses, where to send, how to send. So what can be the example of this data link layer?
Ethernet, Wi-Fi, and point-to-point protocols.
Then first we will write MAC address. Then we will write here switch. Then we will write here bridge. Okay, tell me ARP.
Yeah.
Address resolution protocol. Yes. See, generally we call ARP as a layer 2 protocol. Everywhere you will find layer 2 protocol only. Even in a Cisco packet tracer also, when we will capture the packet, it will show you layer 2 packet, layer 2 protocol only. But what ARP does, it identifies the MAC address of a device with the help of known IP address. It means it is acting in between the layer 2 and layer 3. So we may call it as a 2.5 also, right? But according to the concepts, you have to tell it layer 2 only. But it acts in between them, right? No? So data link layer is responsible for what? Assigning or enabling the communications between the devices based on what? Based on the correct, no? So it means that this data link layer will be applicable when you have to enable the communications within the same network. Because in the same network, what is required to have the communication? Only one criteria, that is MAC address. But when you will move forward, what you require? IP addresses. And in this, what happens? Data units is called as frames. Network layer.
Find the best route to set the data.
So it is responsible for enabling the communication between the devices located in different network based on IP address, right? It is responsible for finding the best path between source and destination if both are located in different network, right? It means still data link layer, what is happening? Communication within the same network. Network layer, the communication will happen, but between different network. What will be the example for this? IP version 4, IP version 6, then routing protocols, correct? But not all the routing protocols. I can write here, let's say, routing protocols like OSPF. Can I write RIP, routing information protocol, as an example of routing protocol coming under network layer? Huh? Yes or no? You have to tell me. No. RIP is which layer protocol? Routing information protocol is which layer protocol? Layer 7 protocol. Application. BGP, border gateway protocol, is which layer protocol? It is a routing protocol. BGP is a layer, routing protocol. So you will tell this is a layer 3 protocol because routing protocol comes on the layer 3 only, but BGP is layer 7 protocol. Don't worry, everything will be clear. ICMP. ICMP is also example of what? Network layer. Data units is called as
Segment.
packets. Clear till here? Next is what? Transport layer. It is responsible for enabling end-to-end communication. It enables segmentation.
Segmentation means that divide the data.
Segmentation of the data into small segments. It enables the transmissions of the data based on sequence number, right? Then it maintains flow control and transmit the data based on window size. See, flow control means what? Window size means what? Window size means the size of the receiver's capacity. This is a receiver's capacity. I have to send this much amount of data. This is I am flow maintaining the flow. How? Because you know that it will happen based on the TCP or UDP. In this, we have two protocols, TCP or UDP. So all this, whatever we have written here, it is not going to be followed by the UDP or TCP. It depends. TCP will follow everything, but UDP will not follow. No? So we'll understand the differences between them later on. But here, according to transport layer, we have to write all these things because all these things, whatever we have written, will be done by whom? Only with the TCP, not the UDP. And that differences we'll understand when we'll write the differences between TCP and the UDP. Correct? So this transport layer is responsible for enabling the end-to-end communications. It enables segmentations of the data into the small segments. It enables the transmission of the data based on the sequence number. It maintains flow control and transmits data based on window size. And apart from that, it also assigns source and destination port numbers. It means in the data link layer, MAC address is there. In the network layer, IP address is there. And in the transport layer, what is there? Port numbers. Port numbers are there. Correct, no? Now, we have to see what all the port numbers we have. Note down this. So these are the three categories of the port numbers. So first is written here that well-known ports, system ports. It means the number from 0 to 1023 is called as a well-known ports. Well-known ports are the reserved port. It means you cannot assign your data files as a well-known port numbers. That's why it is written here that this is with a stricter review process and assigned to new ports than the user ports. But this is going to be well-known, right? Next is what? Registered port. So well-known port numbers can be the example, like say we have certain protocols. So TCP, in that we have certain Telnet, SSH. So they all use certain port numbers. So we'll come to that part. Let's say 23 is the port number of Telnet. HTTP has a port number of 80. These are what? Reserved port numbers. That's why this is the part of what? Well-known ports. Next is what? Registered port numbers. Registered port number is having a range from 1024 to 49151. And this is called as what? This is called as a registered port assigned by IANA with less strict process. Means compared to the well-known, this is less strict. We can assign. But in general, whenever you are having any data, that data will be assigned as a source port and destination port numbers. So that will be done with the help of what? Ephemeral port. What type of port number you will get? Ephemeral port. It means this is a random port number. See, your devices will assign the random port numbers to our individual data. Right? What is the random port number? Here it's telling what is the range? 49152265535. Now, why it is happening? See, consider that here you have a data, right? Large data is there. So what you are doing here, you are dividing it to small segments. Now, this is one small segments of data you have got here. So let's say you are trying to visit a website. So you are using HTTP. So when you are using HTTP, this is what? This is one destination port number. What it is? Destination port number. So where you want to reach? HTTP. What is that? 80 port numbers. Now, from where you are reaching? Source port number, no? Let's say you have got a source port number 64,000, for example. So when this message will reach to the server, so you will get a return traffic also from the server. Return traffic. So when you will get the return traffic, what will happen? Now the source port is what? 80. And destination port is what? 64,000. Correct? Now this message will reach here. Let's say to the device. Router will identify that, oh, this is my destination port number, 64,000. Then it will identify what? IP address. Right? Then what it will identify? MAC address. After that, it will reach the destination. Correct? So whenever you are moving from layer 7 to layer 1, what happens? Encapsulation take place. When you move from 7 to 1, what happens? Encapsulation take place. Why encapsulation take place? Encapsulation means each layer when you move, you add extra information. When I am at layer 4, what I add? You add port numbers. When you come to layer 3, what you add? You add the IP addresses. When you reach to the layer 2, what you add? You add the MAC address. So at each layer, what you are doing? You are adding additional information. So adding additional information is called as an encapsulation. Right? Next, when you move from 1 to 7, what do? You remove that layer, extra information. When you are at layer 2, MAC address is there. When you will come to layer 3, MAC address is done, IP is there. When you come to layer 4, IP is removed, transport layer, port numbers is there. After that, everything has been identified, then real transmission will take place. And here what happens? Decapsulation. What do you mean by decapsulation? removing the additional informations, right? Decaption means what? Removing additional information, right? So when you are in the transport layer, what happens? Based on the port numbers and based on the destination port numbers, communication will take place. Correct? Correct or not?
Yes.
Next, what can be the examples of the transport layer? Transmission control protocol, user datagram protocol, then anything else? Then transport layer security. Huh? Transport layer security, SSL, secure layer, secure socket layer. But when you are explaining this, don't explain all these terms. Just you have to tell only TCP and UDP, because if you have done security, then you can tell that. If you've done CCN and CCNP, then it is fine. Just you tell TCP and UDP, it is enough. Data units is called as segments and datagram. How? When you are using TCP, data units will be called as the segments. When we are using UDP, it will be called as a datagram. That's why both are the data units in the transport layer. Clear? That's why it is written here that transport layer, it segments, reassembles the data, it breaks the large data in the smaller networks. Correct? It breaks large data into the smaller networks. See, whenever you download anything from the internet, let's say a 100 MB file is here. So is it that 100 MB file will be downloaded at one speed only? Small chunk is there, right? Next is what? Session layer. It is responsible for opening a session, maintaining a session, and closing the session. It is responsible for opening a session, maintaining a session, and closing a session. Or we can say terminating the session, not closing, terminating will be a good term. Terminating the session. So whenever the communication happens, so one session is established between the client and the, you can say, server. And based on that session only, the transmission will take place. For example, you are accessing a website, banking websites. You are putting your all the credentials for doing online payment. So you will find one session is established, right? So you have to provide all the details in that session. Once it is done, you have to provide the OTP, then only transmission will take place. If not done, then what will happen? Again, session timeout will be there and you will be logged out, right? So whenever the senders and receivers are there, so between them, a session will be created for having the communications. Once everything has been done, then session will be closed, terminated, right? So what could be the example for the session layer? I'm asking the protocols coming under the session layer. This will be asked. Nowadays, they have started asking the questions. Tell me the protocols coming under the session layer. So you will tell what? SIP. What is SIP? Do not tell systematic investment plan. This is session initiation protocol. Then one more protocol we have, point-to-point tunneling protocol. point-to-point tunneling protocol, like it will be used in the case of VPN, virtual private network, is also example of what session layer only. Now, from this session layer, your data units is called as what? Data or messages, we can say. Clear? What is written here? Session layer manages the session or connections between the applications, establishes, manages, and terminates the connection between what? Local application, that is web browser, and the remote application, we can say web servers. So one more line extra we can write that it establishes the connection between web browser and web server. Means what? See, let's say you want to reach Google server. How will you reach? Using web browser. Google Chrome you will use, Mozilla Firefox you will use. So what it is doing? Maintaining the session between them, right? So web browser is which side? Client side, and web server is the server side. So client and servers. Next is what? Presentation layer. So this layer is responsible for presenting the data into a structured form, right? It involves translations of the data. Translation will take place. If I send you a PDF, what you will receive? PDF only. Image is received. Translation will take place. Encryption and decryption, compression and decompression will take place. Encryption, decryption, same thing only. So here also it is written. What it does, it translates the data into a format that application can interpret, and it also perform encryption and decryptions of the data as it is received. Correct? So presentation layer is responsible for translations of the data. And finally, what we have? Application layer. So it acts as an interface between the user and the network, you can say, or you can say server. So like how we are accessing that? Using the application layer. So in the application layer, what will come? All the protocols of the application layers, right? Examples can be Telnet, SSH, HTTP, HTTPS, SNMP, SMTP, IMAP,
DNS.
POP3, DNS, FTP, TFTP, DSCP, syslog, NTP. Yes, we'll discuss all these protocols. Whatever the protocols I'm writing, everything we'll discuss one by one. Whatever I'm writing, everything is important for the interview. It is very easy to understand. With the port numbers, with the full form, you will be able to do. Just wait and watch. Everything will be very clear. Okay. No, wait. So session layer we did presentation. Okay, so see here what is done. So it provides what interface for the applications to access the network devices, network services. In this, protocols interacts with the software applications. Example can be like web browser or web servers. Interfaces. So like how you are going to access the web servers using a protocol, HTTP. It means here HTTP is providing you like a platform to access a web service. Same as HTTPS will be helping you to reach that particular web service. That's why these are the protocols coming under the application. And after this transport, whatever the session presentation application we have, in this data units, we call it as a data or messages only. Correct? Then what I told you, encapsulation and decapsulation. No? So what is encapsulation? Adding the additional information when data moves from layer 7 to layer 1. What is decapsulation? Removing the additional information when data moves from layer 1 to layer 7. Okay. So meeting we have done, OSI model we have done. Tomorrow we'll start with the TCP and UDP differences. And before that, we will see TCP and IP, TCP IP layers. Layers we have to see. We have discussed this here only. No. After this, we have to see TCP IP model and its layers. That's all. And then we will start with the TCP and UDP differences, 3-way handshake, 4-way handshake, all these things. Now for you, one assignment is there. You have to write packet flow. You have to understand the packet flow, how the data will flow from 1 to 7 and from 7 to 1. Okay, write down the question. Explain the packet flow from layer 1 to 7 and from layer 7 to 1. This is the question. And tomorrow I will ask this. You have to explain me. You have to note it down in your notes. I will see also. All students, for you also, the question remains same. We'll discuss tomorrow. In OSI model. How the transmission will take place, you have to explain me according to the data. Let's say data is flowing from layer 7 to layer 1. Data is flowing from layer 1 to layer 7. How it will flow. What all the information will be added. What are the information will be removed from that. Right? We'll stop the recording.